Let X be normally distributed with mean 25 and standard deviation 6. Use the given mean and standard deviation to fill in the boxes. The first row represents the X distribution, while the second row represents the X bar distribution. Construct the X bar distribution using samples of size n equals 64. So in other words, we're going to look at the distribution for just the original random variable, and then we're going to look at the comparison values or the scale values that correspond to the same number of standard deviations for the sampling distribution of the sample mean. So here's the thing. Okay, let's start with taking down the mean, which is the population mean mu, which is 25, and then the standard deviation of the population, which is sigma, is the standard deviation is 6. Okay, this is our standard deviation. Standard deviation, okay? Sigma means it's for the population, okay? So we're going to use these for the first scale. So we're going to put 25 in the middle, and then we're going to keep adding one standard deviation again and again to get the different values that correspond to the z-scores. So adding one standard deviation, we get 31 for one standard deviation above the mean. Adding 6 again, we get 37 for 2 standard deviations above the mean, corresponding to a z-score of 2. Then adding 6 again, we get 43. And then we will start working from the opposite direction, start to subtract 6. One standard deviation below the mean would be 19, 25 minus 6. And then subtract another standard deviation, we would get 13. And then again, we subtract 6, and we get 7. Okay, so that is the first scale. Okay, that's for the original random variable x. Now, if we start taking samples of size 64, and we take every possible sample of x in samples of 64, we will have a new bell curve of sample means that will have the same mean as the original random variable, but the standard deviation will be slightly different. And this has a special name. It's called the standard error of the sampling mean. So what we want to do is now get the standard error, and all we have to do is take the original standard deviation of 6 and divide it by the square root of the sample size, which in this case is 64. So the square root of 64 is 8, or you can just type it in like this, and then you get your new standard error. So now we can use this to create our scale going upwards and backwards on the the scale for the sampling distribution, the x bars. Now, one little trick you can do is to create some z-scores here in Excel. You can do a z-score of -3, -2, -1, then 0, 1, 2, and 3. And now this will tell us how many standard deviations to add to the mean. So we can do a kind of a quick little, it's a shortcut basically. And we could have done this for the upper one as well, for the mean of the scale of the original random variable. But it was pretty easy to do it by hand because I was just adding 6. Now that we're adding a number with a decimal approximation, I feel it will be more accurate and easier and faster to do it with some help from Excel. So I'm going to start by putting an equal sign underneath the -3, and then I'm going to click on that to say that I want to add -3 times the standard error. Okay, so I want to add the standard error -3 times, and I want to add that on too, so I'm going to add to the mean. All right, now the one thing you want to really make sure here is that the when you click on the -3, the cell containing -3, that you want to leave as a relative reference, but when you click on the standard error, you want to make that an absolute reference by putting in the $signs or using the F4 key on your keyboard. So this will pin that reference in place, and we want to do the same thing with the mean. So I'm going to add, and then I'm going to click on the mean. cell containing the mean, and I'm going to put in the dollar signs. Now, if that feels too complex, you could always just type in the numbers. So click on the cell box for -3, then times the standard error of 0.75. Of course, this may be rounded, so I don't really like you to do it this way because it can cause some round off error depending on the question you're working on. If you're going to do it like that, you probably want to make sure that you round to more decimal places to make sure you have better accuracy. So I'm going to go up to 4. That's usually pretty safe. So what we can see is that this is actually exactly 0.75, so we don't have to worry as much about round off error, or at all really, because 0.75 is easy to type, but just be careful of things that are rounded off too short. Okay, now I'm going to add my mean of 25. Okay, so that's another more straightforward way of doing it if the absolute references are a little too much for you. Okay, now that I have that one, I'm going to just stretch it over and copy the formula to the right. And now I have all my values, which I can either type in or I can copy and paste. Let's see if it'll let me copy and paste. Some of them let us and some of them don't. Yeah, this is going to let us copy and paste. So this will help with just cutting down on typo errors. So you can see, oh, I've already got that one. Let's put this right here. And then this one. And I forgot to do, did I forget to do it for 3? Yeah, so all I need to do really is copy that one more time. And now let's go ahead and submit.